So let's do a cdemo demo. This is a demo environment, an OVA that I built. I restored from a snapshot so I know it's in a good state. One thing you might want to check when you restore is just making sure that you have internet connectivity. The Ansible demo, if you haven't pre-built it, will reach out to the internet. So even though you've installed cdemo, may seem like you don't need internet connectivity. It's always a good idea to check and be sure and do it from your command line prompt, not from inside a Docker container. So I've got everything up here. I like to start and show and again, a reason for having internet connectivity is to show the various info sites that we have. So here's the GitHub repo for cdemo. I like to make the point that this is something that your audience can pull down and do. We've seen this happen where people have actually pulled down and installed cdemo while we're presenting cdemo. So start with that and just show them where that is, GitHub conjure demos/cdemo. Show that this is a full CI/CD toolchain that we've modeled here. So WeaveScope is a cool way to visualize the containers and some of their connections between the containers. So we've got our conjure master here, our command line interface for administration. We've got our Jenkins node. We've got our source code control node. We've got our whole Ansible implementation here, and then Splunk for monitoring. So this is a full CI/CD toolchain, and then we've got the same thing in the UI representations up here. So here's my Conjure dashboard. I'll have to relog into. Here's my GOGS dashboard for source code control, and this will figure. So basically, just kind of showing people where we are, what's in the environment, and then diving into that, so that this is representative of a tool chain. Almost everyone's using Jenkins in some shape or form for build automation. Many times they're using it for deployment automation too, but many times that's also handed off to something like Ansible, and we're using AWX, the open source version of Ansible Tower here. So source code goes in here, it gets built here, gets deployed from here, gets monitored from here. In this environment, my Splunk environment, the dashboard will come up, but it's not monitoring correctly. So even though we see the cool dials and things here, as we spin things up, we will not see these dials move. That's in case you happen to be using this particular version, this OVA that was built back in November. So that's the last I will do out of character. What I will do now is just start the demo with the pitch that I normally use. So, hi, thanks for your time. Wanted to take a few minutes and walk you through a representative CI/CD toolchain that uses Conjure to source its secrets. So we're going to be using Conjure Enterprise, which I have running here. We can see the Conjure dashboard. This is the UI. And what we will be doing is interacting with a source code control system, GOGS in this case, standing in for something like GitHub or Bitbucket or whatever you're using in your environment. We've got our almost obligatory Jenkins implementation. As we've seen, most people are using Jenkins, although if you're using something like Travis CI, Circle CI, Atlassian Bamboo, there are other build automation tools out there, but Jenkins is like carrying the load, often shouldering the entire burden of automation in CI/CD toolchains. So we wanted to show you how we work with that, but also show how we can delegate to jobs that are purely provisioning, purely configuration management, using Ansible's the open source version of Ansible Tower, AWX, and then monitoring that capability. So this is a full CI/CD toolchain that we're using here, and what I wanted to do was really just step through a use case. So let's jump right into this. I'm going to skip the first couple of labs here. I'm going to run this Jenkins build job here, which will spin up some containers. And so when I click build now, what that's going to do is kick off a job that we can watch as it executes. If we click into it, watch the console output, as it spins up some containers. And we can see the effect of that in here in WeaveScope. As those containers spin up, then we can see those containers start to pop up here. What this is going to do is create some containers that represent applications. There's the front end and the back end. So the web app represents the front end, and the Tomcat app represents the back end. These are both really modeling just relationships But we can see that these applications are starting to contact the Conjure master to retrieve secrets. And what they are doing is using an identity that they were assigned to retrieve that secret. So this is the identity that they were assigned by that deployment script. So the deployment script that we ran in Jenkins used a Jenkins identity to create new identities that were assigned to these containers. These containers now have these identities and these API keys that they are using to authenticate to Conjure and pull a secret called secrets/frontend/AWS access key and displaying that secret. So we can see that secret starts with 9292. If we go over to the Conjure UI and look down here, that was secrets/frontend/AWS access key started with 9292. We can see that that's this value here. So what we've done is we've created identities for these containers. These containers are using those identities to authenticate to Conjure. Their policy, which we'll look at here in a bit, authorizes them to retrieve this secret, and then the secret value is this value here. Now we can do a very simple rotation here by simply changing this. Because I'm logged in as an administrator, I can do this. But what I've just done is effectively rotate that secret. And so that application is now picking up the new value of that secret, that all text value that I've just put in. So we've rotated that secret. We've shown how the container was assigned an identity. This assignation of that identity was done by the deployment script. So there's a chain of trust that starts with that Jenkins job that created this container. This Jenkins job was created by a trusted administrator who set this in motion. So the root of all trust starts with a person somewhere, and that person logs in. They authenticate. They create this automation. This automation then runs. It has an identity, and its identity is established in Conjure to give it the ability to be able to pull secrets. So we've got this Jenkins identity here that is created from this automation. That Jenkins identity then creates these identities that assigns to these Tomcat and web app nodes. So we can see where this root of trust comes from. We see that it goes back to the trusted administrator. This is why it's so important that administrator's activity is logged in. This is CyberArk's core business, is handling that privileged access. So your automation administrators, the people writing automation, their activity needs to be rooted in trust. You need to know when they're doing this activity. And so we need to be able to control when they log into these UIs and do this work so that we know only trusted administrators are creating this automation, because then this automation has an identity. And that identity then gets delegated to the identities that they create. So that's a bit about the root of trust. We've seen rotating secrets. Let's look at the policies that created this trust system. So if we go in here and go to my Conjure policy here, we can see that there's several policies, and Conjure policies are written in YAML. But if we look down here at secrets, and we can see that this policy grants access to these front-end variables. So there's a front-end, and this policy starts with secrets, and then it goes to front-end here, and then we have AWS access key. So this policy is loaded under a root policy called secrets. That's extended by the policy name front-end, and then eventually the actual secret name, which is AWS access key. So this is where the name of that variable comes from. And if we look down here at the bottom, then we can see where Tomcat apps get the ability to see, read, and fetch those variables. So we've got this resource called variables. Variables are what we've tagged these secrets with up here. So we can see here's our wildcard name called variables. So basically we gave the Tomcat nodes the ability to access these secrets with that grant. Now if I change that and reload this policy, then we will see the behavior of that node change. So in effect, what if I change this to say secrets here? Let me go in and edit this now. So I'm going to just do a live edit of this policy and change the permission. So we've seen authentication. We've seen where identity comes from, the root of trust, where those identities get assigned where the Jenkins node created the identity of that Tomcat node. And when that Tomcat node comes up, it's going to be authorized based on this policy. And so if I change this policy and change this authorization from variables to secrets, so we've got up here a group of things called secrets, and I'm changing that. So variables was where we were getting the permission to access the AWS secret key. Now we're changing that. And when I save this, what it's going to do is commit that change, trigger a reapplication of that policy, a reload of that policy. And what we'll see when that policy reloads is that the Tomcat nodes will no longer have access to this secrets front-end access key. They will be denied access because now we've changed the permission model. So we haven't changed the identity. They're still authenticating correctly, but now their authorization has changed because we've changed the policy. So it's like giving somebody access to something and saying, oh, now you have access to this other stuff. You no longer have access to the stuff you had access to before. So this gets into authorization as code, security as code. This is now a document that captures the permissions of your various processes. Those processes are authenticated first. Nothing happens without being authenticated. But the authorization rules are established using these documents that can then be verified. We can go back and say, is this document currently in effect? Is our policy model currently the one that we're enforcing? And so this is just a way of defining the privileges of processes once we've established their identity. So if I change this back, and I'm going to do that just so that the fetches keep working, then we would get back the access to those secrets. So I'm going to change this back here when I'm going to edit it. And if I just change that back, when I save it, it triggers a webhook. The webhook triggers the reapplication or the reloading of that policy. And we will give back the ability to access those variables, make sure I spelled it correctly. And so committing that change, then we can watch the effect of that change, that as that policy gets reloaded, then the Tomcat nodes will regain access to those variables and that front-end AWS access key. So we've looked at identity. We've looked at how identity can be assigned by a process. In a bit, we'll look at how identity can be bootstrapped by a node on its own. We looked at rotating that secret, and then we looked at changing the permission models to grant and revoke access to secrets based on a policy model that we've defined in our source code control system. So that's a great first step. That's a great first sort of intro to identity, rotation. We introduced the idea of chain of trust, how the root of that trust needs to be managed by a privilege management system. So this ties back into the CyberArk core value proposition with PAS, as well as with PSM and using PSM to control access to these automation tools. That root of trust then lets us trust that the automation is doing the right thing and that these identities are rooted in that trust. And then once those identities are authenticated, how they're authorized, and then how secrets can be rotated. So that's a great intro, great first step in the demo. So the second step is really to dive more into the source of identity, and that would be where we start looking at how do these identities get created, or how would we bootstrap an identity where we're not assigning it, where there's no sort of overlord automation to assign that identity. And that gets into where we want to, I'm going to just stop these containers. So running build now for stop containers will kill all of these running processes. You can see the connection was closed because all my Tomcat web app nodes went away. So what we're going to do now is look at some of the source of identity, or what's the root of identity. So I've got these scripts here. One which is so the problem in every organization, every tool in this world has the same exact problem. How do you bootstrap identity? Where does identity come from? How can it be trusted? How do you authenticate something that in the case of a Lambda function in AWS, may only live for a few seconds. You can't spend a lot of time provisioning identity to these things. It needs to happen very, very quickly. A way that we provide, and this is sort of the if there's no other option, we have options in OpenShift and Kubernetes on the various cloud platforms for bootstrapping identity there using those third-party resources. But if we have no third-party, we have only a VM or a container that's up and running, this process using a facility in Conjure called the host factor token allows you to create an identity. And so the host factor token is sort of a bearer bond. It is a token that can be redeemed for an identity. And this script will create one of 4 different host factor tokens. So these host factor tokens correspond to groups or layers, as we call them, groups of non-human identities. So in Conjure terminology, a host is a single identity. A layer is a group of non-human identities. So a layer is a group of hosts. Host is to layer as user is to group in Active Directory. So we can give a layer permissions, and then as identities come and go from that layer, they will acquire the permissions of that layer or inherit those permissions. So what we're doing is we're giving, this host factor token allows us to create an identity in a predefined layer. So if I say for example, then I will create, using my root of trust, so I'm logged in as Ava, the administrator. This is the API key that we're going to use to authenticate. And then this is going to allow us, because I have this administrative capability, I've created this host factor token. So this token value now can be redeemed for an identity for this Ansible layer. And that's what the second script does, is it takes that cached value and redeems that token for a value. So we're showing the whole chain of trust here. Here's the host factor token. Here's the new name that we're going to use. So we just generated a name here. And you just pick a name. So the host name is whatever you want to call it. The password or the API key is going to be created for this host name using the host factor token. So that's what happens when I do this. I redeem that host factor token for this name, and now that name has an associated API key. Now we have an identity in Conjure. If we go and look at our Conjure UI now, then we will see, if I refresh this here, in hosts, I now have an Ansible identity corresponding to this name. I can't see the API key. You can never see the API key. You can rotate the API key, but you can never retrieve the API key. That's a fundamental aspect of security. So this API key needs to be retained, and we'll talk about different retention mechanisms and caching mechanisms in a moment. But for now that we have this API key and this identity, we can do something more significant with that, and that is use that identity to pull a secret. So I'm going to use that identity that we created and the cached API key to pull that secret that we just rotated a bit ago in that other demo. So this is the same secret that those containers were retrieving, now using a new identity that we've dynamically created in the Ansible layer. This is a host in that layer. If we go and look at our layers over here, then we can see that there are Ansible nodes, that Ansible nodes have permissions on various things, including those variables that we saw before. So we can read these variables here, amongst of which is the front-end access key. So secrets front-end access key, this is where that permission came from. This identity, because it's a member of this layer, it's a member of this layer because we created that identity from the associated host factor token. If we look up here, we can see that there are host factor tokens, and here is our host factor token that we used to create that identity. So host factor tokens are closely associated with layers. Layers are groups that have pre-assigned permissions. We can use that host factor token to dynamically create a new identity, as we have. That identity then has the permissions of that layer, and that is how that identity can pull this secret. So hopefully that shows you the provenance of identity, the provenance of being, or the ability to dynamically create new identities, to have those identities inherit permissions. We're not having to go through and laboriously assign new permissions to these identities, and then how that identity and its associated permissions can be used to access secrets. This process, the authentication part and the establishment of identity is the only thing that varies. Once we have an identity, authentication happens, or authorization happens in the very same way. So it's really that front end authentication part and how do we establish identities that varies depending on the platform. So in OpenShift and Kubernetes, we can actually use things like a service account or the project or namespace that the application is running in as its identity. And we can associate that identity with permissions, and then pods and containers running in that namespace or running under that using that service account can then use that identity to access secrets. On cloud platforms, we can use IAM roles in much the same way that when an EC2 instance comes up or a Lambda function comes up, its associated role can be verified, and that role can be associated with permissions in Conjur. So this is just a bit of getting into the man behind the curtain. How does the plumbing actually work for identity? And that takes us into the last lab. And the last lab is pretty cool because what it will do is actually create, I've got to find my Jenkins job here, it will create a new Ansible container. So if I run this now, it's going to actually reach out to the internet and it's going to build a new container, a completely new container. If I go into this job and watch it, it's going to be pulling things from, first pulling the Ubuntu layer, and I'll probably pause this video here just to wait for this to complete and come back when it's done. But if you do this the first time you do this, it needs internet access, so just be aware of that. You're doing this demo. So I'm going to pause this and come back when this has finished running because it takes a couple minutes. All right, so that finished, and we can go back over here. If we look in the Weave Scope environment, we can see that there's this cdemo Ansible node. So this is representing a newly provisioned VM. This is typically what Ansible is used for, is creating new infrastructure and configuring that infrastructure to purpose, deploying packages and all the stuff that needs to be set up. So Ansible is just a general purpose automation platform for that. And so what we're going to do is look at this and say, and just go into a shell here and see what's on here. So we've got pull password and secrets.yaml. So we're going to be exhibiting a third concept here called secrets injection. And the idea here is that you don't necessarily want your applications to all be responsible for pulling their own secrets. If the application has to use an API to access a repo directly, that represents a kind of technical debt. You don't really want to rewrite all your applications to use a new repo. So secrets injection is a way of injecting secrets into an application so that the application doesn't have to be responsible for pulling it itself. But the secrets have to come from somewhere, and if they're coming from Conjur, they have to be authenticated. So this is going to use the concepts that we've established already to show you how you can move that identity from inside the application to an open source tool called Summon. And Summon will use the identity that we've established to pull those secrets and then inject those secrets into the application. It knows what secrets to pull with this secrets.yaml file that you see here. So if we look at what secrets.yaml is doing here, it's pulling not that AWS access key, it's pulling a database password. But what it's doing is saying, okay, from Conjur, I'm going to pull a variable named this. The identity here we'll get to in just a moment. But it's going to pull this secret, put it in an environment variable. That's what this syntax means. That environment variable is going to have this name. So the application doesn't have to know where secrets came from, doesn't have to know anything about Conjur. It will use the environment variable and the associated value that environment variable has. And that environment variable's been populated by Summon. So question is, where does this identity come from? This is a brand new Ubuntu node, and it has no Conjur identity established. So what we're going to do is use Ansible and that whole host factory pattern that we just talked about, to assign an identity and lay down an identity for this node. It's going to be put, those identity files are going to be put where Conjur looks for them by default, and that's in several files named Conjure in the /etc directory. So you can see there's nothing there right now named Conjure. So we're going to fix that, and we're going to do that using an Ansible job. The first thing that we need to do, though, is take that host factory token that we created over here. So this is the value that we can use to create new identities for Ansible. So I'm going to copy that to my clipboard, and I'm going to go over to use this host factory token in this job or in this policy that we've set up, this code that we've set up for Lab 3 in this Conjure identity. And so what we need to do is go down here and update this file with this host factory token. So we're going to edit this file and paste in the value of that host factory token. So I'll do that. It's on my clipboard. So I need to put that here, and then I want to validate cert. I don't want to validate certs. This is a value that you have to change if you're using the enterprise version of Conjure. So I can leave that true if I'm using the open source version of Conjure, but because I use the enterprise version of Conjure here, I need to validate certs. It's a little bit more strict about that, and we don't have that cert cached in order to check it. So I can save this, and that will establish the basis of creating an identity for this playbook that we're going to run over here in the tower to actually execute this. So I'm running in my templates. I'm going to run this Conjure identity push template here, and by clicking the rocket, I simply launch that. So what this is going to do is fire up a playbook that will go through. We can actually watch it execute. It will use that that document, the values that we set over there with the host factory token, to push, as the name implies, an identity onto this Ansible node that we've created here. When we get finished, these files will be populated here. So when this job gets through running, then it will create identity, or the identity documents that are needed for this secrets injection to take place on that Ansible node. So we just watch it run here. It's creating this folder. It's installing summon. It's doing all the stuff that we needed to do here. You see that we had no failures here. So demo God's willing, we should now have Conjure files that that basically establish the identity of this node. So we used the host factory token pattern that we walked through over here, same exact host factory token, to create a new identity for this node. If we look in Conjure here under hosts, then we should see a new identity. Oh, look, there it is, cdemo Ansible. That's the identity of this node. If we look in these files here, there's 3 files. One is the configuration. So this basically is where is the Conjure service, so that this identity knows where, what to talk to in order to retrieve secrets. Then we've got the identity file, and this is exactly analogous to a .NET RC file. It's got the name and the API key that this node, this host, needs in order to authenticate to Conjure. And then here's the cert that's needed to establish that the Conjure server is what it says it is. So, and encrypt traffic, obviously. So if we look at each of these in turn, here's conjure.conf. This is saying, where is my Conjure master? Here, where is my cert? Where is my identity? So this is just the default that the Conjure APIs will use, and that the summon tool, more importantly, the summon Conjure provider will use to find the Conjure service, find the cert, use an identity to retrieve those secrets. Second part of that is the Conjure identity file. We can see there that this has our name, host demo Ansible, and then here is our API key. Now these files are, if we look at the long version of them, these are set up as read-only for just the identity file is set up as read-only, not to the world. So this is just good practice that you don't want everyone to be able to read this identity, because this has the credentials for authentication. It's not perfect, but this is what we have to work with in the VM worlds. And as I said, we have a much better many much better resources where we have a third party, like a cloud platform or an orchestration platform like Kubernetes or OpenShift to validate against. So we have our identities. We now have the tools that we need in order to run this pull secret script. So if I run pull password, then we can see that we're using summon to grab this secret password, and this is that password. Now, if you remember, we're looking at a slightly different secret here. I think we're looking at the database password. We'll go find that and just make sure that we're pulling the same value. So here's SQL password. Here's front-end database password. I think that's the one we're pulling. We go over here, back over here. We've got 1B79FFF. 1B79FFF. If we change it here, again, just going through our rotation, and come back over here, rerun that. Now we get the new password. I just changed it to all text, and we see that that's the value there. So that takes us through the majority of the use cases that can be exercised with cdemo. You've seen just the general model of a CI/CD tool chain where we've got source code control, we've got build automation, we've got configuration and deployment automation. We've got a way of visualizing this. And then, of course, our secret store with Conjur. We have seen how to rotate secrets. We've seen that chain of trust starting with the automation engineer and how that needs to be rooted in a privileged system like CyberArk's PAS for logging into that system, for creating automation that can then be trusted to create new identities. We walked through the host factory token pattern that can be used to create new identities in pre-established layers that have pre-established permissions. We saw exactly how that worked with creating a new node and pushing a new identity to that with Ansible, and then using that identity to perform secrets injection using summon. So that's a whirlwind tour of the capabilities around Conjur in a real-world context using real-world open source tools. Go forth and prosper.